Hi everyone, my name is Naveen Karuturi. I'm truly excited to be speaking today at Conf42 Machine Learning 2025. Today, I'll be discussing a mission critical topic, optimizing high availability and disaster recovery strategies for cloud SAP systems. In today's digital world, downtime isn't just inconvenient, it's expensive, disruptive, and can cause major operational risks. To give you a sense of just how important SAP systems are, SAP forms the backbones of critical business operations for organizations around the world. In fact, about 84% of Fortune 500 companies rely on SAP to manage their enterprise resource planning functions, covering everything from finance and supply chain to human resources and customer services. And it's not just about big enterprises. Over 92 million users interact with SAP platforms every single day across more than 180 countries. This is incredible scale. A key point to highlight here is when SAP systems face downtime, it's not just a technical issue, it's a major business risk with a global ripple effect. So, building a resilience in SAP environment isn't just optional, it is absolutely essential. Let's dive into the key strategies that ensures SAP systems to be available, resilient, and ready for anything. First, let's take a moment to understand the real world impact of SAP system downtime. Every minute a core SAP system is offline costs an average of $8,750. And without proper high availability strategies, incidents can stretch beyond 4 hours. This adds up quickly, leading to over $2.2 million potential losses per incident. Beyond the financial implications, the operational impact is more alarming. 84, 87% of organizations experience significant supply chain disruptions within just 8 hours of SAP downtime, and 64% report customer facing impacts like service delay and transaction failures within first 2 hours of system unavailability. These cascading effects underlines a vital truth: downtime isn't just a technical inconvenience, it's a major business threat. It disrupts not only the internal processes, but also damages the customer trust, brand loyalty, and revenue streams. This clearly shows us building resilience isn't optional, it's a mission critical. So now the key question is, how do we build resilience? Now that we have seen the real impact of downtime, let's dive deep into the two key strategies that organizations use to build resilience: high availability and disaster recovery. Although they sound similar, they serve very distinct but equally important roles. First, let's see with high availability. High availability focuses on maintaining continuous system operations and even during component failure. It eliminates single point of failure within a primary production environment using redundancy and automated failovers. Typically, it operates within the same region, leveraging availability zones. It usually adds up 15 to 22% of the base infrastructure cost, which is a smart investment to avoid costly downtimes. Let's discuss the examples of high availability. If a single SAP server fails, HA ensures that system continuous functions seamlessly. User does not even realize anything went wrong. For an example, if a storage device fails over, the secondary storage component will take over, and then user sees seamlessly these transactions with the component failover will be very seamless in the case of an HA. Now let's discuss about the DR, disaster recovery. Disaster recovery addresses large-scale disruptions, things that can be bring down entire environment such as data center-wide outages or natural disasters. DR enables business continuity by recovering SAP operations in alternative geographic locations. It usually spans multiple regions to ensure true geographic isolations. However, implementing DR can increase total cost by 28 to 47%, depending on the organization's recovery objectives. Let's consider an example of DR. If an hurricane wipes out a data center in Florida, DR allows recovery from secondary data center, let's say in Texas or wherever it is, quickly and reliability. And here is the important insight to observe here. Organizations that implement both HA and DR strategies experience over an average of 35% fewer operational disruptions compared to those with only partial implementations. Such as like if company operates only HA, then they don't they don't have the benefits of 35% fewer operational disruptions. So they need to implement both of these things to ensure like it achieve 35% of 35% of fewer operational disruptions. When SAP landscapes are properly configured, companies can achieve up to 99.95% system availability, even in the face of failures. Now that we understand the differences between HA and DR, let's move forward how organizations are actually putting high availability into a practice. By looking at the graph stats, 87% of our production SAP environments today have some form of a basic high availability measure in place, which is a great progress. But here is where the gap becomes clear. Only 53% of these organizations have fully documented and properly tested disaster recovery plans. And this is concerning because even though 76% of respondents classify that SAP systems as business critical, many still operate without full disaster recovery protections. This tells us something important. High availability isn't alone enough. Without disaster recovery, organizations still exposed to significant risk, especially during large-scale disruptions. High availability and disaster recovery must go on hand in hand and to truly protect the business operations. Now let's take it deeper into exactly how we build effectively high availability, starting from very foundation layer, infrastructure layer. Building true high availability starts with a strong foundation, and that foundation is infrastructure redundancy. We start with compute redundancy by deploying SAP applications across multiple availability zones. This way, if one zone or hardware component fails, the application continues running seamlessly in another. Then we have a network redundancy, which means setting up redundant network paths, load balancers, and multiple virtual interfaces. This eliminates single point of network failure, which are often silent risks. And of course, storage redundancy, leveraging a cloud storage platforms that automatically replicate data, achieving extremely highly durable levels even up to 99.99%. Each of these compute, network, storage acts as a safety net. Individually, they are powerful, but together they form a solid and resilient high availability foundation. And it's not just about a hardware infrastructure. Level redundancy is just as important to maintain the true resilience. Before moving on with the application resilience, above infrastructure foundation, we have one more layer, database resilience. Which is the one of the most critical parts of SAP environment. Let's discuss about the database resilience. Across leading database platforms, there are proven high availability solutions designed specifically for minimizing downtime. Let's discuss in this presentation HANA, SAP HANA, Oracle Database Card, SQL Server always on. For SAP HANA system replication, maintains a real-time standby instance, enables recovery times as fast as 2 to 5 minutes. It is extremely popular. About 84% of SAP HANA deployments rely on it, and 65% of has fully automated failovers. When it comes to the Oracle Data Card, provides synchronous or near synchronous replications for SAP systems using Oracle databases. Typically, it achieves recovery time within 3 to 7 minutes after primary database failures. Let's move on to the SQL Server always on. Is used for SAP on SQL Server platforms, implements availability groups. It achieves average recovery times of around 4 minutes after a failover. After a failure, and is adopted roughly 71% of SQL-based SAP environments. So across databases, whether it's an SAP HANA, Oracle, or SQL Server, the message is consistent. Replication and failover are not optional. They must tightly integrated and into any serious high availability strategies. And now that we have covered the database redundancy, let's move forward and explore how we build the resilience for application layer. Now moving up the stack, let's talk about application level redundancy. At this layer, we create a resilience by load balancing multiple SAP servers. This ensures that if one server fails, other instantly take over and maintains about 95% normal transaction throughputs without the users even noticing. For SAP Central Services, that ASCS and SCS instance, we deploy clustering solutions. These allow us to avoid single point of failure, enabling recovery time averaging just 2.5 minutes. And it doesn't stop there. Ensure replications ensures that critical in-flight transactions are protected, even if the primary NQ servers goes down. All of these are backed up by automated failure mechanisms, which can detect component failure and instance recovery within 12 to 30 seconds. But what should we know here is the infrastructure components we have discussed here. But what happens if the entire region or data center goes down? That's where the disaster recovery comes into play. Building a resilience isn't just about preventing small failures. It's also about readying for larger regional disruptions. That's where disaster recovery strategies add a critical second layer of protection. At the foundation, we start the regular backups, ensuring we always have recent reliable copies of our SAP data. Next, we implement cross-regional replication, which ensures that even if an entire region suffers an outage, our data is still protected and ready in another location. And finally, we bring it all together, recovery orchestration, automating the entire recovery workflow. So when a disaster strikes, recovery is fast, smooth, and minimize the human errors. When all the three layers, backup, replication, and orchestrations are executed properly, mature disaster recovery strategies can shrink recovery times by 72%. That means cutting a downtime an average of 18.7 hours to 5.2 hours, making a huge difference in a making a huge difference in how fast an orchestration can bounce back. By looking at this, normally orchestration can bounce back. Now let's explore how major cloud providers AWS, Azure, GCP enables enhances high availability and disaster recoveries in the cloud. When it comes to the resilience, major cloud providers offer powerful tools, but each has its own strengths. Starting with AWS, AWS holds 37% market share. 78% of user adopts multi-AZ developments, boosting availability from 99.95 to 99.98%. EBS snapshots and elastic disaster recovery services achieve faster RPOs of 1 to 5 minutes and RTOs of 15 to 30 minutes. Moving to Azure, with 32% market share, Azure's availability zones delivers to 99% availability. Site recovery and Azure backups ensure RPOs of 5 to 15 minutes and reliable SAP certified backups. And GCP. GCP holds 24% market share. The regional persistent disks and cross-regional copy backups are widely adopted and enable fast, seamlessly recover across the regions. The key takeaway is every cloud has building blocks of HA and DR. Choosing the right fit for your SAP landscape is what truly makes the difference. Now let's move on from the cloud responsibilities to how we should design and implement these solutions for real world success. Now that we have seen what tools and strategies are available, let's talk about how to implement them effectively. First, begin with the business requirements. Start with the business impact analysis to prioritize what's crucial. Typically, organizations allocate 8 to 15% of SAP infrastructure budget towards resilience. Second, layer your defense. Protect at every layer: infrastructure, database, and applications. Multi-layer protection increases rates to about 92% compared to the 63% of single layer setups. Third, automate where possible. Automation speeds up recovery and reduces human errors. Automation process improves success rate by 89% versus 62% for manual effort. And finally, test regularly. Organizations that perform quarterly recovery drills nearly doubles their success rate during the actual disaster recovery events compared to those test once a year. Ultimately, it's about building the muscle memory, because when a real crisis hit, practice makes resilience. And finally, after all planning and preparation, how do we know if it is truly resilient? That's where key matrices like recovery time objective and recovery point objective comes into play. As we near the end of today's session, let's focus on how we measure resilience. There are two critical matrices every organization must define: recovery time objective, recovery point objective. Recovery time objective: the maximum acceptable time is to restore system functionality after disruption. Recovery point objective: the maximum acceptable amount of data loss measured in time. But it doesn't stop there. Continuous improvement through regular testing and refinements is essential to strengthen recovery capabilities. Organizations that clearly define operational these matrices achieve recovery times 42% closer to the business requirement, experiences 58% fewer business disruptions during recovery operations, and on an average, recovery 2.6 times faster, reducing recovery from 12.3 hours down to 4.7 hours. As cloud and SAP technology evolves, mastering RTOs and RPOs will be a key for maintaining competitive advantages and ensuring true business continuity. And with that, we have completed our journey through optimizing high availability and disaster recovery for SAP systems. Let's move on to wrap up today's discussion. Thank you.